VLSM, and I'll have to give you a VLSM assignment. So last week we finished the ARP and we started some work in VLSM, some pre-work in VLSM. So today we're going to go straight into finishing VLSM. Next week, we will make some cables in class and either DHCP or some other topic, right? Depending on how the time goes. Because we wouldn't be able to spend the whole session making cables, right? So let's go to our...
So the quiz off.
You're supposed to get quiz next week too.
Well, I was wondering because I don't know how much we'll be able to do.
Yeah, you
All right.
appointed that Monday for both quiz on
Right, I put quiz
object
here.
oriented.
Yeah, right. Okay. So let's see. So quiz 1 is here. So let's put that in red and see if I can remember.
I mean, if
So,
we need to cover more to have the quiz, that's no problem. But
well, I was just going to check that.
yeah,
The thing about it is that we have 1, 2, 3, 4, 5 classes again, right? And out of that 5 is 3 face-to-face. So I don't want to give any quiz like and one after the other sooner. So
right.
now is a good time for it. Your last one, I'd like to keep that online. Yeah. And hopefully we wouldn't miss any. I don't know, graduation is not on a Monday, right? So that shouldn't affect you. So let's see. Let me just pull up quick and see what my last quiz was about, if I'm going to give you that, or well, one like it now. So let me just ask you some questions here, right? You all know what's the default mask for class A, class B, and class C address, right? Yes or no?
Yes, sir.
Yeah.
Yes, sir.
If anybody in this class is repeating, you could tell me, send a direct message to me in the chat. I don't want you to tell everybody. I'd like to know, because if you're having trouble and you're getting the same trouble that you had last time, I'd like to be able to help you, and I could only do that if you tell me. Okay? Let me know. And so you all know, if I tell you a network address has and I give you the subnet mask of a network address, and you could tell me how many hosts can be accommodated on that network. What's the formula?
Two to the n minus 2.
Very good, thanks. And if I tell you that I want to have like fixed VLSM, if I tell you I need to have 10 subnets in a network address, how many bits I need to borrow from the host portion to subnet? Can you tell me that? You could tell me, feel free to type it into the chat if you like.
That will be 2 to the 4. That will be 16, okay, 110, because if you do 2 to the 3, it will give you 8, which is not, so it'll go one step above.
Sounds good. And if I give you network address or subnet mask in binary, in digital, and you could give it to me in binary.
Yes, sir.
Yes, sir.
And if
Yes,
I give
sir.
you it in slash notation, and you could give it to me in binary and
Yes, sir.
and decimal.
Yes, sir.
And
Yes,
if
sir.
I give it to you in binary, you could give it back to me in any 3 forms. You could give me in the other 2, right?
Yeah.
Yeah.
Nice. And if I give you some network addresses and subnet masks, you could tell me if these addresses are on the same network or not.
Yeah.
And you could give me some how you call it. You could do fixed length subnet masking, right?
Yes, sir.
Good. Yeah, okay. Well then, that together, what we will do tonight, you will be prepared for your quiz. Right?
So
Wait.
if you could, sorry, if you could just go back through the last slide in the last upload that you have with the um, subnets and the addresses and so on being on the same network. If you could just run back through that for me, please, at some
Did
point.
you practice it over the weekend, over during the week?
Yes, sir.
And what exactly gave you trouble? Tell me.
I don't know. I just still having a hard time like figuring out whether they're on the same network or not. Like I kind of figured them out, but I'm not 100% sure.
Okay. It's on the slide?
Yeah, yeah.
That's what we was doing last week.
No, at the end of the VLSM slide, just now. Huh? Yeah, the last page on the VLSM slide.
How was this set of slides?
Uh, nah, I don't think so. Under host TCP/IP configuration, that's the name of the document.
Okay. That's this one, right? Don't worry. This one.
Correct.
Okay. So, so work out right now for me, and everybody participate in this, please. I'd like to see your answers in the chat, right? Convert this to binary for me, please, and put it in the chat. I need you to do it. And I need to see you doing it. That there are 34 people in class. I need to see some responses, please. It all should be, just copy it and paste it or wherever, or type it in the chat. If all it take long and all you do it, Or they're staying here till 8:30 tonight, not me. I don't have a problem, I'm home already. But not one single person pieced it in yet. I am not doing it. I'm waiting for Alia and we had to finish the material. Right, so Karen is there. Let me see some other people putting it. Last week, Wednesday, we had a class. I forced people to put in things and they determined that was best class ever because they had to do things themselves. They actually learned stuff. So that's 3 people. I'm checking to see if they are all the same. 4. So there are 30 people who ain't do nothing yet. Are waiting. 5, 6, 7, 8. 9, 10. 11. Make sure you do it in such a way that you can reproduce it in our class on pen and paper. So if you go and cheat by doing it on our website, that's on you. So the other 14 people, I have to beg you to do it.
Excuse me, sir.
Yeah.
Do like you put full. You see how you have full stops between the decimal. Well, I'm not sure. Oh yeah, decimals. Do you have to put that in the binary, or you can leave that out?
What do you think, class? Anybody?
You have to put it.
You have to put it. If you look on the slide, there are 4 fields separated by a period. So the normal thing is like this. Look at it here in all of them. That is how you have to do it. Okay, so I think most people get it correct. I ain't seen none wrong yet. Very good. Now, this address, convert this to binary for me, please. So it should be even faster because you have the first 3 fields done already. So let's see that. As 1, 2, 2 people so far out of 34. 3, 4, 5, 6. Mari, check back that for me, please. I don't know which one you was doing, but that's not the one we should be doing. Mari, you need to check your last field. Isa checked your last field. Zurich, check your last field. It's 62. We should be converting.
Sorry, sir. Total 64, yes?
Yep. So that's less than half the people participated. See, if last week when we was doing it, then we wouldn't have to go through this tonight, right? And when I was doing it on the board, people was just watching me and not doing it. I'm not saying you was doing that, who asked the question. I'm not saying that. I'm not thinking. I know that there are people who is getting it wrong because they couldn't remember. I'm glad that somebody asked the question. There's no worries at all. Okay, so Zurich, check again. That last field is still wrong. Right. So what happens now? Most people get it correct. Right? Now, convert this to binary for me, please. The mask. I'm waiting for you to paste it in. Come on, I could do faster. Let's do it and move on quick with this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Zurich, check that last field, please. Oh, Zurich, sorry, you did the previous one. All right, you did the address. Now you're going to do the mask. Okay, so everybody got the mask correct. I don't have to say anything. So how many ones? The 255 is easy. That's 8 ones, right? How many ones are in the mask? Pop it into the chat for me, please. I've seen different values. Come on, people. It definitely is not 24. If the 255 is 8, then the 325s are 255s alone is 24. And you still have the 192. So that's still 2 more. So 192 is 2, right? 128 plus 64. So most people got 26, right? So that's pretty good there. Thank you. Now, so if there are 26 ones in the mask, right? Then what you have to do now is compare the first 26 bits here with the first 26 bits here. Okay? And that is easy to check because this is the first 8 bits. That's the same in both. Then this is the next 8 bits. That's the same in both. Then that's the next 8 bit in both. So the first 24 bits are the same. Is that enough to say that they are the same network address? No, we have to do all 26 bits in the mask. This mask is 8, and 816, and 824, and 2 here because the last one is 11000000. So we need to get the first 2 bits in the last field, and this here is 0, 0, 0, 0, 0, 3 and 2, 5, 6, 7, 8. So this is 0, 1, 2. And this part here with 62 is how much? 62 is dot no 128, no 64, right? And then you'll have 132, 116 is 48, 18 is 56, and 4 is 60, and 2 is 62, and 0 ones. So this would have been what you would have had in the last field. So you'll see that these two bits here would be the 25th and 26th bits in the network address. So that means that the first 24 bits, first 26 bits, are they the same in this and this? And if the first 26 bits are the same, then yes, they are on the same subnet. Okay? So if they are on the same subnet, right?
Sorry, can you repeat that?
What?
The first what?
The first 26 bits are the
Okay.
same in both addresses. How do we get 26 bits? Because the subnet masks say 26 bits is the network address, right? That means the remaining 6 bits would be the host address. So since they both are the same, then they are on the same subnet. So if they are in the same subnet, that means that this host can communicate with the gateway, which means that this host could send such stuff outside to other networks, right? Is that clear?
Yes, sir.
So was that easier today? Now?
Yes, sir. I just wanted to make sure I was correct.
Yeah.
I
No, I
was.
mean, but other people, are you okay? Did you get some stuff today?
Yes, sir. So I just wanted to just double check. You said once the host IP and the default gateway IP address have the same network ID, they're on the same subnet.
Yes. If they have the same network address and the same mask, it must have the same address and the same mask. And this here says they all have the same mask, right? So yeah, they both have the same mask.
Okay.
So all we need to check is the network address. Just for curiosity, let's do this one, the second one. So convert this to binary, please. And convert this to binary. And convert all of them to binary. And paste your answers in, please. Same thing, holes now. I ain't seen no answers yet.
Doing all of them, please, sir. Hold on.
Okay, cool. Right, so I got one answer. Right. So people get stuck. Sure, which question you on?
One second.
So you would find that this here, well, if you convert this, you will see this is 8 and 1 is 9 bits. So the mask is /9. So you check the first 9 bits in this one and the first 9 bits in this one. And it should be the same, is it? 8 and 1, 9. Are they
No,
the
sir,
same?
it's not the same.
It's not the same because in this one, 254, there's a 128 bit. So the 9th bit in this is different from this one. So they are not on the same subnet, right? So this machine, this device may not be able to communicate with the gateway. One of them has to be wrong. And if the gateway is wrong, then none of the other devices on that network could connect to the outside. If the gateway is correct, then it means that this one is on the wrong network and will not be able to connect to any device on the network. Even though they even though the network, the gateway is bad, because this one is on another network, because of the address, he will not be able to communicate with any other device, neither inside nor outside the network. And then you do the same thing for the other two, right? So are we okay? Do I need to do more or are we okay now?
So I think we good.
Anybody has any questions on it? Good. So thank you much for that question. I am sure that other people would have benefited from it, right? It's just they didn't do it yet or they didn't know. That's sad, eh? Anyway, so we continue now with the slide where we left off last week, which would be, which one, boy? The name of that slide was which one? The one with VLSM. Slide 11. So I hope you went through and did these questions and whatnot and did some practicing and reviewed route aggregation and variable length subnet mask and so on, right? We still have to do route aggregation yet somewhere. I hope you could do these, right? We just went through some of that exercise and you heard some of these coming in the quiz. So we reached up to here. And we did some of these in class. And I'm hoping that you would have done it.
Yes,
Yeah.
sir.
Do you
Yes,
need
sir.
me? Do you need me to do this or are you okay?
No,
Remember,
sir.
if you don't have a mic, you could talk to me on the chat. All right. If anybody not okay, you can tell me. So I'm guessing now because of the answers that we are okay, because some people would communicate with me directly and not to everyone on the chat, right? All right, good. So we continue now the classless network. And why is it classless network? because we have this here right away. In classical networking, those would be 8, 16, and 24 bits, and we don't have to say it because it is understood. So those will be your default mask. So it's none of those, so we know that it is classless. We have this. So in this one here, our classless network has 28 bits. That's 8 and 8, 16 and 8 is 24, and 4 bits from the last one, which means that we had borrowed 4 host bits. Okay? 32 minus 28 is 4 host bits. So which 4 bits is the host bits? It would be the last set in the address. The host addresses are formed by adding numbers in the range 1 to 2 to the power 4 minus 2. Right? That's the number of hosts we could have. The first one is all zeros, and the last one is all ones. So it's not 2 to the 4 minus 2. I think it's going to be 2 to the 4 minus 1, because the part with 0 is the network address, and the part with 1 is the broadcast address. So the range will be from 1 to the 2 to the power 4 minus 1. Okay, you all got that? Anybody didn't understand that, tell me?
So I can just repeat that one more time.
The host addresses are formed by adding numbers in the range from 1 to 2 to the power 4. They say minus 2, but 2 to the power 4 minus 2 is the number of addresses, right? So these two that we minus in is the first one, which has 0, and the last one, which ends in 1. So to get the number of host addresses
yes,
is 2 to the 4 minus 1, right?
Yes, sir. So
Yes,
you
sir.
have
Good. So there's the network address. All right. The network address here is 8 and 8, 16 and 8 is 24 and 4 is 28. So it'll be 192, 1, 2, 3, 4, 5, 6. Dot 228. 228 is what? 128. And 62 is 192. And 32 is 224. So that's only 4 more. So no 16, no 8, 1, 4, no 2s, no 1. And the other one is 17. Right? So that is no 128, no 64, no 32. 116 and 1 more. So no 8, no 4, no 2, 1. Right? Dot 0, 0, 0, 0, 0, 0, 0, 0. 4 and 4, 8. So the network address is given by the first 28 bits. That will be up to here. Right? So the host addresses will be all zeros all the way up to, well, not the host address, to all ones, right? This is the network address. The whole network address is with all zeros in the host part and the original network address. So this here will be your subnet bits. Okay? And this here would be your original network bits. This will be your subnet bits. And these will be your host bits. All zeros, the whole thing here gives you your network address, and with all ones and the rest will give you your broadcast address. So you're going now from 0, 0, 0, 1 all the way up to 1, 1, 1, 0. So yes, this last address is 2 to the power 4 is 2 to the power 4 minus 2. Yes. No. It's 2 to the power 4 minus 1. Right? Because this is 8 and 614 and 115. So we were correct, 2 to the power of 4 minus 1. This is 15. And right. So what happened is I told you it's minus 1. It's actually minus 2. That's correct. Because the 2 to the power of 4 is 16. So this here is 2 to the power of 4 minus 1. That is the last value with all ones. And this value will be 2 to the 4 minus 2. Right. So I tell you something wrong just now. My bad. Right. So this is correct. Up to 2 to the power of 4 minus 2 is going to be 1 to 8 and 6. 8 and 4, 12 and 2 is 14. So it's 1 to 14. 1 to 14 will be your host addresses. 2 to the power of 4 minus 2. 2 to the power of 4 minus 1 will be the broadcast address. If you put all ones, if you have any number of bits, the maximum value that could hold is 2 to the power of n minus 1 if they are all ones. So the maximum value it could hold is 15. That will be a broadcast address. And minus 1 will give you your last host address there when you minus something. So the host addresses go from 1 to 14. 2 to the power of n minus 2. So this is correct. I just got think for a little bit there. My bad. So we okay with that? So look, the last host here is 14 and the first host is the network address is 0 and the first host is 1. So we go from 1 to 14. I hope you all see how we got that.
So am I running back that one more time?
What am I running back?
The I kinda get confused with the 2 to the n, with 2 to the n subtract 1 and the 2 to the n subtract 2. Because
Okay.
because if you're having 4 zeros and as your host, right? There's your host bits, right? And you're basically adding one binary. So you know the 0000 is your network. That is part of your network ID, and the host begins at 0001.
Right.
Then after your broadcast should be 1111.
Right. Look at here.
Right. All right.
So your broadcast address is 2 to the power of 4 minus 1. That's your last value.
That's your last value.
Right?
Okay.
That's 15. 2 to the power of 4 is 16. You
Uh-huh.
have 4 bits. 2 to the power of 4 is 16. Minus 1 is 15. That's the maximum value you could get with all ones in 4 bits.
Yeah.
Right? That is your broadcast address.
Confirm that.
Right. The last network address, host address, will be 1 less than the broadcast address.
Yes.
Now the broadcast address is 2 to the 4 minus 1.
Mm-hmm.
And so the one before that will be 2 to the power of 4 minus 1. That's your broadcast address minus 1.
So is
So
it
that's
2
2 to the power of 4 minus 2, which is
2.
equal to 14.
That's your last host address.
That's your last host address. 2 to the power of n minus 2. Okay?
Yeah, I wanted to double check that.
Right. So that clears that up, right? So sorry if I confuse you. So we could take off all these things now. Here now, right? We got the broadcast address for this network is this, the 15, which is 2 to the power of 4 minus 1. Good? If we're using 4 bits, 1, 2, 3, 4, that has 16 possible values. because it's 2 to the power 4, it's 16 possible values. The first value is all zeros. That means we have 15 more values. And the last value is all ones. So that means that you take away 1 here, you take away 1 here, that's 2. Out of 16, that remains we have 14 more addresses going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, right? 12, 1, 1, 0, 0. I could just make some space. Oops, sorry. I could just make some space. I put in that below. So this is 12, 13, 14, and the last one would have been 1, 1, 1. And this is your broadcast address. So all your values go from 1 to 14. We know that this is 2 to the power of n minus 1, and n is 4. So this here will be 1 less than this, so it'll be 2 to the power of n minus 2. I hope that's clear for you guys.
Sir, I'm still
Yes,
a bit confused though.
Yes, Micah, what are you confused with?
Like, yeah, I'm still confused about 2 to the power of n minus 1 and 2
What
to
is
the power.
confusing about 2 to the power of n, Micah? Tell me what about it that's causing trouble. What you don't get with 2 to the power n minus 1?
No, I'm more confused like why you put 2 to the power of n minus 1 to begin with.
Because, Micah, let's say you have 1, 2, 3, 4, 5 bits, right? The maximum value for this, if you convert it to base 10, is when it's all ones, right?
Yes.
Yes? Yes. So we have 5 bits here, Micah. Now this is arithmetic I'm teaching you here now, eh? There are 5 bits, and I said it earlier, I'm just saying, so you'll know that I do say it when I'm talking. There are 5 bits here. This is 1 plus 2 plus 4 plus 8 plus 16. 16 and 8 is 24, and 4 is 28, and 2 is 30, and 1 is 31. So the maximum value you could get 5 bits is 31, right?
Yes.
Right. But there are 5 bits. 2 to the power of 5 is how much, Micah? You could work it out on your fingers. 2, 2s are 4, 2's 8, 2's 16, 2's 32. So the 2 to the power of 5 is 32. We see that for 5 bits, the maximum value is 31. And what is that equal to? 2 to the power of 5 minus 1. In any number of bits in binary, any binary number, right? How much ever bits you have, if you have b bits, the largest value you can have is when they are all ones. And that is 2 to the power of b minus 1. That's the largest value you could have. Right? Over here, so we see that with 5 bits, the largest value we could have is 31, which is 2 to the power of 5 minus 1. Generalizing, 2 to the power of b, the number of bits minus 1 is the largest value you could have. And that means all the bits are ones. Here, we have 4 bits. The largest value we could have with 4 bits is when they are all ones. And this value is 15, which is 2 to the power of 4 minus 1. So the broadcast address is 2 to the number of bits minus 1. Okay? The last possible host address is 1 less than that. Where is 1 less than 31? 30. Where is 1 less than 15? 14. But remember, 15 is 2 to the power 4 minus 1 is 15. 1 less than 15 is 14, which will be 2 to the power 4 minus 1, and you minus the next one. So this is 2 to the power 4 minus 2. 2 to the power 4 is 16, by the way. 16 minus 2 is 14. Why is 2 to the power 4 minus 1 important? Because if you have 4 bits, 2 to the power 4 is the number of values you could have from 0 to all zeros to all ones. But the largest value you can have is when they are all ones, which is 2 to the number of bits minus 1, as in up here. Mike, are you with us now?
Okay, so you use 2b minus 1 when you have to find the highest number of bits when all the bits are equal to 1.
The highest
And-
number of bits, Micah. Careful what you're saying.
While the broadcast, well, when all the bits are 1.
Which is the
And-
broadcast value, right?
Yeah.
So
And
that's 2 to the power of b minus 1.
yeah, and 2 to the power of n minus 2 is when you have to find the maximum host in
The
the
last
addresses.
host, the highest
Yeah,
host address,
All right.
right? Yeah. So you
Right,
can use 2 to the n minus 2, or you could just put all ones and 0 and convert it to base 2, right? To base 10, sorry. So what's tripping you up here is not the concepts, is you are trying to generalize something when you don't know your arithmetic, because you haven't done it enough to internalize the points I am making there, even though I've been singing to you, practice it from day one. So now you know what you have to do, right? Good. Any questions? So we come here now, and you have a classless network, A, B, C, D, 1, 2, 3, 4 fields with some value slash X. It means the X is telling us that the first X bits are the host bits, right? And that means since there are 32 bits here, and we minus X, we will get the Y bits, okay? So whatever 32 minus the mask here in slash notation, that will give you the number of host bits, okay? Host addresses are formed by adding numbers in the range from 1 to 2 to the power of y minus 2 to the network number. So 1 is the first host address, and 2 to the y minus 2 will be the last host address, and you'll add that to the network number, which is what we have been doing. So we're going to do this now. We're going to do this exercise now on this page, and I'm going to wait for you to put in your answers. What are you going to do? You are going to convert this network address to binary for me, please. Convert that to binary. Do that now. I'm looking out for 37 entries in the chat. So let me see that in binary, please. So I'm now looking out for 38 entries. Somebody keeps getting dropped off. With the network, I know that can be frustrating. Yeah. I see some people drop off 3 and 4 times and come on. I think that was Ethan Clark who just dropped off again. So I don't know if his network is giving him trouble
No,
or
sir.
if he is driving.
I only had one drop.
Or you, right. So, right, Ethan is here, Isa is here. I'm trying to remember who else getting, somebody getting knocked off a lot.
So that was probably me. I just reached home, so I switched from my phone to my laptop.
Excellent. Yeah, no, but somebody else dropped again. Because 2 seconds ago we had 40 participants. No, after Majid, after you, somebody else dropped off. Right. So let me see how much people put in answers here. $200. Michael, if you have to do it by hand, well, you could do it by hand for practice, but for now you could use your calculator or wherever it is you want to do. Just make sure you could do it. You will be able to use calculators in the classroom, but if you could do it by hand, you'll save a lot of time. All right? So what we have here, if we change this to binary, what you will get is, let's see, for 200, it's 128 plus 64 is 192. 192 and 8 is 200. So there's no 32, no 16, 1 8, right? No 4, no 2, no 1. Right? So that's the 200 part. 192, well, if you remember, we just said 128 and 64 is 192. And so everything else is zeros. Dot. Then we have 28. 28. There's no 128, no 64, no 32. There's a 16. Sorry. I'm saying, you see how sometimes your head and mouth and hand not connected? I was saying no 128 and I put 1. So it's no 128, no 64, no 32. So in 28, there's a 16. So I have 12 left. So out of 12, there'll be an 8. And how much is 12? 4. So there's no 2s, no 1s. Right? That's the third thing. And the last one is 46, which is no 128, no 64. There's a 32. And how much that's going to leave? 32 and 14 is 46. So there'll be no 16. there'll be an 8, and 8 from 14 leaves 6 more. So there's a 4, 8 and 4, 12, and 2 is 14, and no ones. Those are my 4 fields, 1, 2, 3, 4. And they tell me that the is 30. 30 bits is my my network address. So 8 and 8, 16, and 8 is 24, and 6 is 30. So that'll be my network address. See it? Yeah? So what will be my first host address? So in this network, we will pull out the first 30 and say that is the network address in binary. So there should be a field here for binary. So my first host address would be this whole thing here, which was what? 1, 1, 0, 0, 1, 0, 0, 0, dot, right? 1, 1, 1, 2, 3, 4, 5, 6, dot, check me for making mistakes, right? 0, 0, 0, 1, 1, 1, 0, 0, dot, 0, 0, 1, 0, 1, 1, right? So my last 2 bits, the will be 0,
So it'll
1.
be 0, 1 for the first host address.
That's my first host address. Thank you. My last host address will be the same thing, but with the 1, 0. The last bit is 0. And my broadcast address will be the same thing with all ones in the host portion. See it? And what was my network address? The same thing with
All zeros on
all zeros. See it? So this first one out here, this is my network address, my first host, my last host, and my broadcast address. See it?
That's it. So that means 47 will be a broadcast and 46 will be the
Say
last.
that again.
200.192.28.46 will be the last
Right.
host
Yes.
address.
Yes. So this here with 46 is the network address. Sorry, not 46. Wait is
The 2 zeros will be the first, that will be the network address, and then with the
right.
01 will be the first
So
host
this
address.
is 32 and 8 is 40 and 2 is 42. Right? So the network address will be dot. Is it? No, that was 46. How much you get?
I say it'll be that 40.
This 128, 64, 32. No, 32 and 8
Dot
is
44.
40 and 4 is 44. So
Yeah.
dot 44 is my network address. Dot 45. So the first 3 fields is the same, right? Only the last one we interfere with. Dot 45 is my first host. Dot 46 is my last host. And dot 47 is my broadcast address.
Let's see.
So what's on the column? It said that is the network address.
Where?
The first column, that is the network address, is there?
When they say the network address, that's the network address of a device. It is a network address of a device. /30, right? So the part with 46, this is the network address of the device. So the network address of a device is the IP address, right? The address of the network itself is the part with zeros in the host portion. You with me?
Okay. So one of the IPs in that is the
Yeah. Yeah. So
Okay.
this 46/30 was the last host address. See it?
yeah.
But the network address, right? When you convert the whole thing, this is the whole thing we converted to binary, right? And we identify the first 30 bits, right? This first 30 bits. That is the address of the network with zeros in the host portion. See it? The first 30 bits is the same in all. A network address is not complete until it has all 32 bits. So the address of the network, the IP address of the network is the host portion must be all zeros, and the rest together will give you the actual address of the network. Right? So understand the language. When we say a network address, we mean the address of a device on a network. But if we want the address of the network itself, it will be the address with zeros in the host portion.
So just a quick question. I understand what you're saying. For the example that they had created with 120.18.50.224,
Where that is.
that is the 1, 2, 3, 4, the fourth example.
And this one.
When I did the calculation and I left that as the network address, I got the answers that they gave. So that's why I assumed that these were the network addresses and not the device address, but I understand what you're saying.
Right. So we will do this in a minute and check it, right?
Okay.
So you'll get a chance to clear it up. I'm glad you brought that up. I feel so very happy that you actually did it. And you see the point I'm making now to the rest of the class. You know what? Okay, who asked me that question just now? Tell me your name, please.
Ethan.
Ethan, right? I don't want to say the fellow who just spoke, right? So the rest of the class, I don't know if anybody understand what Ethan just asked. But Ethan was able to ask me a very direct and clear question and tell me what his problem is. I can go now and I can fix that. Whenever we reach that point, we can fix it and we know what exactly he is asking. Because now Ethan knows exactly what caused him a problem. So when people ask me questions and I ask you exactly what is your problem, what is the question you're asking, what is it that has you confused, that is what I am asking. And sometimes people are not able to answer that because they have a vague notion of something and they're not quite sure what it is because they ain't reached there yet. You understand what I'm saying? So the more work you do on your own, in addition to learning more, you will also be able to identify what you don't know. And if it is something you're supposed to know, then you can bring it up with me in class. Yeah, guys? Yeah. Thank you, Ethan, for demonstrating that point that I have been trying to make so long and saying this is a real example now of how that works. So we're going now. The second one is going to be a real easy one. Convert that to binary for me, please. It's really easy. 10, no 128, no 64, no 32, no 16. It's 10. So it has 1, 8. That remains 2 left over, no 4, 1, 2, and no 1. So this is 10. Yeah? Dot 1, 0, 0, 0, 0, 0, 0, 0, 1. Real easy. Dot 0. Well, 0 in binary is 8 zeros put together. So we just repeat that. 1, 2, 3, 4, 5, 6, 7, 8. Good. We see here that the network portion is 20 bits. 8 and 8, 16, and 4 is 20. So I can separate that right away there and know that this is the network portion. This is the host portion. Right? So this here, by the way, will be my network address. What will be my first host? My first host will be this same address, but with 1. All zeros in the host portion and 1. That is my first host. Then, right, I notice people not pasting and stuff like mad. Right, should have been. Then my last host will be the what? That, but with all ones in the host portion, which will be 1, 2, 3, 4 dot, oops, dot 1, 2, 3, 4, 5, 6, 7, 0. That is my last host. That looking like a 1. So let's put LAST, last. Ah, 0, right. And then what will be my broadcast address? Right?
So, seeing that the default for class A is 255.0.
Okay, 1 second. This would be my broadcast address. Right. So you're saying since the default address for our class A is what?
255.0.0.0.
Right. So only the first 8 bits.
Okay. The other the other 12 bits would be that would automatically belong to subnetting. That would be the subnetting part.
Well, it could be. Yeah,
it
it
could
could
be.
be. Right.
Could be.
But
Okay.
remember, we're doing classless networking.
Yeah.
Right? So
Understood.
we're not even worried about what class it belongs to. We really don't care about that. Right? The
Yes.
routers that receive this message with this as the source address or destination address or whatever, it take care about nothing. All it cares about is identifying this will be the network address. How it get this to be the network address? Well, the first 20 bits is, we identify the first 20 bits because of this. Oops, just now. Oh boy, just now. Whoa, madness. All right. So I come out of it, so I don't think I could go back into it again. So the first 20 bits is the network address, and the last 12 bits will be all zeros. That will be my network address. Okay? That's all.
Yes.
So you all see how we get the network address, the first host, the last host, and the broadcast address. Good? Come on. Right. So let's erase that. This one, right? Do that for me now, please. We're gonna do them all to make sure that you all could get them.
The one with 157.788.0, right?
Yes. Yes. So 150 is 128. That leaves me with 22 more. So no 64, no 32, 116. That leaves me with 6 more. So no 8s, 1 4. That leaves me with 2 more. And no 1s. See how easy it is to change it? Dot 77, no 128. But so I still have 77. So I can take out 64. That leaves me with 13. So there are no 32. I could get 13 and 16. That leaves me with 3. So there's no 8, no 4, 1, 2, 1, 1. And I make sure I have 8 bits. Right? Did I get it correct? For 77. This is 64.
You got 13 and 16.
Oh yeah, it's the other way around.
Yeah.
16 and there's no 16. Right. So I do it the other way around. I got 13. Right. So let's go back here. So there's 64, no 32, and I have 16. I can't get 6, I have 13 remain. So that's, I do the same thing again. So there's no 16, so I still have 13. So there's an 8, no 6s. So there's 4, 8 and 4, 12, no 2s and 1. Is that correct now? Wait, how much digits I have here? That's 9 digits, something wrong still. Let's go back. No 128, there's a 64, no 32, no 16, there's a 13, sorry, 8, and 4, 12, no 2s and 1. Is that correct now? Dot.
Yeah.
Then we have 88. So it's the same thing. What was this one? 77. Very close, right? No 64, no 30, no 128, 164. So I have 24 remain, right? 64, no 32. I can get a 16, leaving me with 8. Right? 64 and 16 is 88. No 4s, no 2s, no 1s. That correct now? Class?
Yes, sir.
Yes, sir.
And the last one is 0. So 1, 2, 3, 4, 5, 6, 7, 8. Right? And they say that the network portion is 22. So we will we'll separate the last 10 bits. 22 minus 32 minus 22 is 10. So the last 10 bits is the host portion. So with all zeros in the host portion, that is my network address. Right? And with all zeros and the first one, that is my first host address. And with all ones, 1, 2, dot, 1, 2, 3, 4, 5, 6, 7, 3 and 3, 6, 7, 0. That is my last, right? 4 and 4, right? And my broadcast address is with 1 in the last day. Yes? And we can convert this to base 10 very simply by having, if you watch it here, this is, what was it? 150 dot 77 dot 88 dot 0. Oops. That is my network address, right? And this one is 150 dot 88 dot, sorry, oh boy, dot 77 dot 88 dot 1. That's my first host address. Yeah? Then my last host address is 150 dot 77 dot, what is this one? 88 and 2 is 90 and 1 is 91. And you all get to 91 here. Remember there's a dot here, right? Dot, and this whole thing here with 0 is the whole, if all was all ones, it would be 255 minus 1. So it's dot 254. And this one will be what? Same thing, 150 dot 77 dot 91 dot 255. Any questions here on that? No questions? Everybody good? Say yes.
Yes.
Yes, sir.
Okay. So what we could do is this one, they have the answers for you already. And the reason they put it for you is not that that means there's one less to do. It means we're going to still do it, but we'll be able to follow the process that we have been using and see if we get it correct in this. So we know there are 29 bits here, right? 29 bits in the network portion, and there's 32 altogether. So it's only the last three values, the last three bits will be host portion. So let's take a look at that and see what we're going to get. So 120, of course, no 128, there's a 64, right? And then we still have what? 56. So there's a 32. So that means we still have 24. So there's a 16, means we still have 8. So if I put 8 there, that should leave no more. So no 4, no 2s, no 1. Is that correct, class?
Yes, sir, that's what I have.
Right. And then now 18 means that there's no 128, no 64, no 32. In 18, we'll get a 16, right? And so we have 2 left over. So there's no 8, no 4s, 1, 2, nothing left over, no 1s. Dot. See if that's correct. Then we have 50. No 128, no 64. There's a 32 and 18. That would give me 16. No 8s, no 4, and 2, and no 1s. Is that correct, class? And the last one is 224. 224 is 128, and 64 is 192, and 32 is 224, and then 1, 2, 3, 4, 5, 6 zeros. Is that correct, class?
Yeah.
Everybody agree with them? Let me know.
Yes, sir.
Good. And there are 29 bits in the network portion. So if I go back, 1, 2, 3, 32 minus 29 is 3. So that is my network portion, my host portion. So with all zeros in the host portion, that's my network address, my complete network address, right? So my first host will be this, right? With 1 in the, all zeros and 1 in the bit, right?
Yes, sir. It will come to 225.
Good. That is my first host. My last host will be the same thing, but with all 1s and a 0 will give me my last host. And the same thing with all 1s will give me my broadcast. Okay? And we converted that back to base 10. Let's convert it back to base 10 so that we will get it. So base 10 now, this is, what it is, 120, right? Dot. This part will be how much? 18. I only spreading it out because of how the thing is, eh? So you, oops. Oh boy. What did I do? Come on. Oh God. That's why I hate this thing, you know. Wow, okay, where did I reach? We're gonna do it. Let's do it by hand. So that's 18, and this piece will be what? 18 and 2 is 20. This is 50. Right? 32 and 16 is 48 and 2 is 50. And this is 224. Right? Slash 29. That's my network address. So the host address will be the same thing, 120.18.50. Dot, there's a dot somewhere here, right? So this will be 224 and 1 is dot 225 slash 29 is the first host address. So remember, the network address is not complete without the subnet mask, right? Then this will be the same 120.18.50.226, right? No, that's 226. Nope.
So it should,
This
I don't
was
think it,
225. So this is how much? 224 and 2 is 226 and 4 is 230, is it?
I don't think it should affect much, but we have nine binary values in the last octet. But I don't think it should.
Oh,
Yeah. But the calculation is still the same, so
3 and 3, 6 and yeah, but it's still, this is 3 and 3, 6 and 3, 9. So we'll have to fix that. So this 0 is wrong, right? All right, let's fix it properly so nobody will be confused. I type it a little too much and put that 0, right? So here is 229, right? 24 and 5 is 29. So that's my network address. This is my host address, which would be a 1 in the last bit, my first host. So the only problem was that I had an extra 0 here, right? But thanks for pointing it out to me because people would have had problems with that, right? 1, 2, and a 0. That will be my last. And then we have all ones. That would be my broadcast address. Now remember, in everything, right, the complete address will have a /29. Okay? So we're gonna do it we did it in, wait, is base 10, which would have been what? 120.18.50. Dot how much? 224/29. That's the actual network address.
Yes, sir.
Okay. And then this one will be 225 because it'll be 224 in the network portion plus 1 here. And then this one will be 224 plus 214 will be 230.
Yeah.
And the last one will, of course, be just one more. So that will have to be
231.
231. So it's good. You see, we do it like this. We make mistakes. So you understand where the mistakes come from and where the values come from. Okay.
So to the
So
assignment.
is that correct here? Like 225. Remember the Disney network port address. First host, last host, broadcast address. Yeah, somebody asking about which assignment now. The
yeah,
VLSM one, the FLSM one.
Yeah, they had only asked for one. I can't remember which one of the fields they asked for. It's in binary. Do we need for
If you can't remember, I
decimal?
can't remember either.
But no, I was asking if you need to put all the addresses as binary, if we could leave it as decimal. No?
It will be good for you to practice, put in both, so you'll get practice in the maths. People are having
Okay.
trouble with the maths, not the concepts. So when they got stuck and they get confused with all the ones and zeros, they get in trouble, which is why I'm doing it the way I am doing it, so they wouldn't have that problem. Yeah?
Could we edit the PDF and just add in our
You could do it over from scratch in Word if you want.
Okay.
Right? If you can't fit it in the thing you have in the PDF, you could do it in Word and send it differently if you want. Put it in a format that you want. Okay? So do I need to do the next two or you're good now? People?
That's
I'll
fine.
tell you what, I'd leave it there. Go ahead, say what you're saying. Hello?
Just send me good too.
All right, great, thank you. So I'm leaving it. And if you get trouble, you could talk amongst yourselves. You all have everybody's thing in our group, our WhatsApp group. So you could ask the question and get the answers. And if you ain't get from nobody and think, feel free to ask me next week. I will do it for you. Good? So here is classless subnetting. So this here, what this thing was doing was basically subnetting. But so you work out what subnet you're on. You identify what is your subnet using the slash notation for the subnet mask. And then you could tell what will be the first host address, the last host address, and the broadcast address using these concepts. Okay? Yeah, you could use this, or you could do it the way I just did. So classless subnetting is performed in the same way as classful subnetting, right? Exact example, that is to be subnetted to give 5 subnets, right? So let's get the first, we're gonna do it the full thing anyway here, right? We're gonna do this to get 5 subnets. How they get these 5 subnets, right? So if we subnet in this, they said they want to give 5 subnets here, right? So what happens is, when we look at this, we should convert it. How many subnets, possible subnets, can you get in this, with this network address? Anybody? The first thing you do is you convert it to, how do you have 1, 2, 3, 4, 5, 6, 7, 8? How come they have 8 subnets here?
So you could get,
So not 32.
yeah,
They're saying this is, the network portion is 23. That means the host portion is 12. Sorry, 9 bits, right?
9.
23 and 9 is 32. Okay? So, and this is the address they give you. So how they get in 8 subnets? They talk about 5 here, and then bam, you see 8 here. And that's it. 1, 2, 3, 4, 5, 6, 7, 8. Anybody else confused? Anybody want to tell me what's going on here?
3 subnet bits
How you get 3 subnet bits?
from 20
You are
to
saying
20.
there are 3 subnet bits. How you get 3 subnet bits?
The original CIDR was /20 and the subnet addresses have /20.
Right. So they give us the original address here had 20 bits, but down here they had 3. So that means they borrow 3 host bits and make subnet bits. And they take 3 host bits from here and they make 3 subnet bits. So how many subnets we could have if we have 3 subnet bits?
8 subnets,
How you get that?
2 to the power 3.
So number of subnets is equal to 2 to the power of 3, which is equal to 8. Very good. So if we have 3 subnet bits, we can get as many as 8 subnets. But we don't have to have 8 subnets, because suppose we only wanted 5 subnets to begin with. We only wanted 5 subnets. But because of this restriction, we couldn't have used 2 bits. If we did use 2 bits, we would only get 4 subnets. So by force, we have to use 3, which means that we will get the 5, and we'll have 3 subnet portions waiting to be used. Yes? Are we clear now, class?
Yes,
Yes,
sir.
sir.
Very good. Anybody didn't get that and want me to explain it again? All right, so class, you are witnessing it. Everybody say they understand. Okay, so what we're gonna do here now, we're gonna take this 192 to and base 10, and we're gonna convert it to base 2, which is 192 is 128 and 64. Right, that's 192 dot 228 is 128 and 64 is 192 and 32 is 224. Oh boy. Right? Then 224 and 4 is 28. So no 16, no 8, 1, 4, no 2s, no 1s. Right? Now I'm doing this over and over and over. So if you're getting it by now, it means that your timetable is kind of slow, right? But you'll work on it. So 16 means no 128, no 64, no 32, 116, no 8, no 4, no 2, no 1. Right? Dot. If I was doing this on a Word diagram, on a Word document, I could have had the different colors as we did before. So dot 1 is 0, 0, 0, 0, 0, 0, 0, 1. So the 20 bits is 8 3s are 24, so 16 and 4 is 20. That is my original thing, right? So let's make life easy. And that's not it. Oh boy. All right. I was just trying to get access to my Word. And so I'm going to share with you in 1 second. I'm ready to share now. Right, so there's the network address. There's the network address we are given. And so this portion here, this 20 bits, network portion. Now notice I didn't put network address because I don't want people to go away feeling, well, the network address is it's just that alone. The network address is the whole thing. The whole entire thing is the network address. But only this part is the network portion with zeros in the rest is the actual network address. So then over here, this is the host portion. So when they come and they give us this address, right? They give us the same address, /23. Okay, that means that this tree here is the subnet portion, right? So now we could come here and put in here that this part here is the subnet bits, subnet. And this part down here is our host portion. You with me? Anybody didn't understand what I just did? Any questions?
Yes, sir. How come for the I just had a question, I mean, I missed that part where you have the why is ending in 01 and not 00 for the network address?
This here supposed to be 0. This is the address that we were given when we
Yeah.
convert this. So this really shouldn't be 1. I
Okay.
shouldn't have had the 1 there because this here is what we converted and we got this. Right? Yeah?
So following.
This is 192.228.16.0/23. Yeah?
Yeah.
So this
Uh-huh.
is the network address. Right, let me bring it back around so that it could fit. Agreed? This is it in base 10. Good question, you are right. I think I'd started, that's how come I get the 1 there. Right?
Okay, so the question is my confusion lies with the slash notation for this question because it was at /23, then you went to /20, correct?
No, it was /20. That's the original thing we were given.
Oh, that's original. Okay, there.
Yeah, let's look back at the slide here. It's performed in the same way as classical subnet. An example, we given this address, right? That's the original address you're given, and that is to be subnetted to give 5 subnets. So we only want 5 subnets, but we can't get exactly 5 subnets. We could get 2 subnets, 4 subnets, 8 subnets, 16 subnets, and so on. Right?
Yes, sir.
So because we want 5, we borrowed 3 host bits to give us 8. But we only really want 5. Okay? Which 5 we're gonna take out of the 8? We don't know. You could take
I have a
anyone.
question. Why are you borrowing 3 in first place?
Well,
That's
you're
easy
borrowing.
enough.
Because we want 5 subnets.
Yeah, 5 subnet. That's why. So 2 to the power 3 will give you 8 because you do have 5. So the
2 to the power 2 is 4. That's not enough.
Yeah, and
So
after
2 to
you
the
need to
power
increment.
3 is 8.
Okay.
Yeah? Now, Zurich, we did borrow in subnet bits when we did FLSM, right? I'm sorry to tell you, you were sleeping during that time.
Most likely, sorry, sir.
But that's the truth of it. No, I ain't vexed with you for asking the question. I'm just saying that that's the way it is.
Yes, sir.
Right? Up to this morning, you sleep in class. So apparently what I had to say was not important. And you know everything. So
Nah, sir, nah. Sorry.
no, I am. That's your call in a partner. That's up to you. It's just I know I set in the exam and I am marking the question I am marking the papers, I'm a given marks and thing. So if I was a student in class, I want to hear everything the lecturer have to say, especially if he set in the exam and marking the papers. But like I said, that's your call. I can't force nobody to listen to me. And was attempted to tell you, well, if you had to sleep, go home and sleep, don't sit in my class, it's rude. People will misinterpret that and say something different. So I ain't want to go there. So people have ultimate freedom in my class. Yes? So we're going again. So this, by the way, will be the first subnet address. Okay? So I don't need to mark that. I could put that over here. I ain't even about to mark that. That's the first subnet address. And it's first because it's the one on top. Right? Then what we're going to do is we're going to get now the first host on that first subnet. So the first host will be a 1 here. See it? Now notice we still had to put the subnet mask because an address in classless subnetting is not complete until we have put the mask. Okay? If we convert it to base 10, right, it will be 1. Yes? And so this is your, not the network address. I can put it down here. It is the first host address. Right? And we go in again. We want the last host address. What is the last host address? It is all ones in the host portion and a 0. So we're going to convert here 1. And then, oops, we're going to take these here and put 1, 2, 3, 4, 5, 6, 7, and a 0. So this is the last host address, which will be, now remember, although I have different colors, we still have to group them in bits of 8 to get the fields. So this is 16 and 1 is 17. Right? And this here is what? 2, 5, 4. Yeah?
Yes, sir.
And so this here will be the last host. And when we paste in that, the broadcast address will be all ones in the host portion. So this will be broadcast address. And that will be what? 17.255. Oops. Yeah? So we got this was the original address, which looks like this, but we separated it into network portion and host portion according to this 20. The first 20 is network portion, 8 and 8, 16 and 4 is 20. And then we have the host portion is the remaining 12. Okay? We borrowed 3 bits. That will be these 3 in the host portion to make subnets because we wanted 5 subnets. So we want 5, but say what? You gotta take it. It's free. What you gonna do? And with that now, it means that this portion here is the host portion. So if we have 3 bits per subnet, that means we can have 8 subnets. And we have here 9 bits in the host portion. That means we could have 2 to the power of 9 minus 2. 2 to the power of 9 is 512. Minus 2 means we could have 510 hosts on each of these subnets. That's pretty plenty, right? But we're doing that to show you it can cross boundaries. It could cross the dots. It could even be all the way up here and have thousands. So this here is our first subnet. Okay? The rest are going to be very easy. Let's see if our first subnet is correct. Where we had 16.1, 17.254, and 255. Let's check what they have on the network here. Right? See? First host address is, why is she seeing all this? Let's go to, right. So you won't get confused. See? 16.1 is the first host address. 16.0 is the first network address. And the last host is 17.254. And the broadcast address is 17.255. Yeah?
That's it.
So the next one from here, let's go to the thing here. What is the next address that comes in sequence? The next address will be to add 1 to this. If we add 1 here, We'll go all zeros here, 0 here, and over here we'll get 1. Let's see how that works. So this will be our second subnet. So if we add 1 to this, we'll get all zeros here, and this will become 1. So our second subnet will have 1 there. You see, our first subnet was all zeros. Our next subnet will be 1. And the how you call it? This is still not, we still in fixed FLSM and this with classless. So this is like a review helping you with your assignment, right? Oops, just now. So what we had here, we got this correct, right? We come here now and we add 1 to the first, to the last broadcast address, and it brings us to this, right? All is 23, so that's fixed. We'll go into the thing just now, right? Into the variable length. So what happens here now is we add 1. That will take us to our first host. So it will be what? 17/1. So this is 16 and 1 is 17.
So that'll be 18. Remember
Sorry,
the zero.
18, right? Because it is in the 2 part, right? Not 1. 18, thank you. So this will also be 18 and 18 and 18. And our host portion, this will be 1. Our thing, this will be 254, and this will be 255. Yeah? Check it out now. We're going to do our third subset, our third subnet.
So the last, sorry, if you can
Go
scroll
ahead.
back up, the last two for the broadcast and the last host, that wouldn't be
18 and 119.
Yeah.
You see how we went 16 to 17 here? So it'll be 18 and 1 is 19. Thank you for paying attention. And this will be 19. Very good. So this part here is 19. 16 and 2, 18 and 1, 19. And then this remains 255. So let's do it this time again in a third one, and let's see if we're going to get it correct. So if we add 1 here, add 1, this plus 1, okay, we will get the next thing when you add 1, 1 and 1 is 2, that'll give you 0, carry across the 1 and 1, you go all the way across here, and you'll end up with 0, 1, 0. This 1, the next part here will be 2 in this part, regardless of the place value. So we will get here, our third subnet will be 0, 1, 0. So all our subnets will be 0, 1, 0. And here will be 0, 1, 0. I hope I'm doing this correct. And then this part will be the same. So when we convert it now, this will be 16 and 4 is 20. Remember, this was 19. 19.255. We use up all. So the next value have to be 20 in the subnets. So this will be 20. 20. And if you double check here, it'll be 20 plus 1 will be 21. Oops. 21. And here will be 21. See? So all zeros will give you the network address. All zeros and 1 will be the first host. All 1s and 0s will be the last host. And all 1s will be the broadcast address. Yeah? You see how easy they are to work out? Then we're going to do the fourth subnet. And that will be what? So the first one was 0, the second one was 1, the third one is 2, the fourth one will be 3. Right? Yeah. And
Yes,
this
sir.
will be 21, 16, and 420, 16 and 420, and 2 will be 22 after 21 here. The next value is 22. And this one here, with our 1 here, will make it 23. And here will be 23. .0, .1, .254, .255. And here's what I'm going to do now, right? We're going to skip and go down all the way to the 8th subset, the last subnet, EIGHT, the 8th subset. So the 8th one will be, this here is 3rd, then you'll have 4th, 5th, 6th, 7th, right? Remember, 0, 1, 2, 3, 4. So 0 is the first one, 1 is the second one, 2 is the third one, 3 is the fourth one, 4 is the fifth one, 5 is the sixth one, 6 is the seventh one, 8 is the eighth one. Sorry, where is now? Oh God, I confuse you.
7
I am
is 8.
sorry.
7 is 8.
Yeah, but I want to do it over so nobody will confuse. 0 in the subnet portion is the first subnet. 1 is the second, 2 is the third, right? 3 is the fourth, 4 is the fifth, 5 is the sixth, right? And 6th is the 7th, and 7th is the 8th. So you have 8 subnets, but the value of the last subnet is 7. 0, 1, 2, 3, 4, 5, 6, 7, 8. So number 7 is the 8th one is number 7. So 8, I'm sorry, it wouldn't be 8. How do we get the last one? It's gonna be all ones, that's 7. And we just say that? That's 7. Right? And when we convert that to base 10, this is 16, and 8 is 24, and 4 is 28, and 1 is 29. Is that correct? No, wouldn't be 29, my bad. 16, 128, 64, 16, and 8 is 24,
And
and
4,
4 is 28, and 2 is
30.
30. So this will be 30. So this will be 30, and this will be 31, and this will be 31, right? So 31.0 will be our last network address. 3130.1 will be our last, our first host address in the last subnet. 31.254 will be the last host in the last subnet, and 31.255 will be the last broadcast address. Let me just show you something here. If we come and we add 1 here, this is our last one, right? If we add 1 to that, what will we get? 110000 dot 11100100 dot 0010. 0, 0, 0, 0, 0.1, 2, 3, 4, 5, 6, 7, 8. Right? And we saying it'll have, if we convert this now, you'll get what? 192 dot 228 dot, what will
32,
this be here? 32,
32.
right? Dot 0. And if you watch here now, how many bits is this? That's 22 bits. But remember, according to this, 8 and 8, 16 and, sorry, 19. This is 19 bits where this one is, right? The problem is we not supposed to change nothing over here. That part is fixed. So when we come and we add one here, we change in this. It means that we interfering with here. So we cannot go any further. See it? We cannot come and change this. We're not supposed to change anything here. And if we add one more address here, one more, we're going into this area where we're not supposed to interfere with that. So this is not going to be allowed. Yeah? So I'll just put a note here.
The red area is a network ID. I mean, you're not touching that.
Yeah, we can't touch that. You see the part that they give you here? Sorry, not here. Let's go to our here. They tell you the first 20 bits, right? You cannot touch the first 20 bits. That's important. So if we try to do one more, we'll be going into it. So what happens is we did the first, the second, the third, the fourth, and the eighth, because by now you get all the patterns. The thing about it, you don't have to use all. You could use the first and this and this and this and any other one, right? Any 5 you could use out of the 8. You don't have to use the first 5. Any 5 you could use. So if you come now, right, how does this work? You want 5 subnets, right? So very simply, it could be that, so I'll just use this part here. You get a connection and you get a router, and you could do 5 subnets. 1, 2, 3, 4, 5. So you have 5 subnets right here. Or it could be that you want to do this, right? 1, 2, 3, right? Or rather 2, 1, 2. Where are your 5 subnets here? This here is 1, 2, 3, with only 2 addresses being used. 3, 4, 5. See, that's 5 subnets there. And this one here, because you're connecting to a router, you're only using 2 addresses. Seen it? There's no other thing connecting onto this network. So over here, right, in each of these, you can have a switch or some device, and you can connect your machines. And over here, you have an address here and an address here. So if you come and you use all that address, 250, 510 addresses. Remember, each one could hold 510 addresses. Here, you're using 2, so that means there's 508 wasted. Okay? So you could do that. If you're doing it like this, and you can have 1, 2, 3, 4, 5 subnets, then you could have the 510 on every one of them. Right? If you connect an all. So you could use that 5 subnets in any way you see fit. Now, so where were we here? Any questions on that? So that was like a full review on VLSM, right? So we could do that in this network. You could go ahead and try it. I would leave this for you to do it with the same thing, 3 subnet bits and borrow. You can try it and you can let me know if you want any help with that. But it's already 7:22. So this one, do that, let me know. So with variable length subnet masking, right? Just one sec, let me just check something here. Right. With variable length subnet masking, the subnetting process can be repeated on an already subnetted network. So in other words, in this here, remember I showed you this, each of these networks could have 510 hosts. Okay? Each of these, I could go and subnet them back any way. Right? Let's take a look here. So what happened is we just saw that we had a thing come in. We have a router and we have 8 possible ports on it, but we are creating 5 networks. And over here, we could come and put a switch, right? And put the 510 devices or wherever we want. But we know 510 is plenty. What I could come and do now, I know I'm getting 512 addresses. I could come here and I could put a router here, right? And then I could come and break this up now into any number of networks I want that I need with that 510 addresses, and I could break them up how I want here and create a next subnet. And then I could take this one and break it up into more subnets. Yes?
So I have a question. When you keep doing that, would you get a smaller, like you would just keep like some form of decrement of hosts?
Yes, it has to get smaller because at the end of the day, the most you could have on this whole thing was 512 addresses. And every time you put a subnet, you decrease it by 2. Because on this subnet now, you could only have what? 2 to the power of n minus 2. So you get, with this whole thing, when you put all on one router here, right? You would have had, each one will have 2 addresses you can't use. When you come and take this one and put it on the next router, now each of these have 2 addresses you can't use because there will be broadcast address and network address for these subnets. And when they come here, each of these will have 2 less. So in addition to being smaller, you will also have more addresses that you are unable to use. So it does keep getting smaller and smaller. There's a price. But the thing is, each small one is going to be a little bit more manageable. Right?
Yeah, and this way, well, I have no wastages. Well,
you reduce the wastages.
Yeah.
It's more efficient.
Yeah, little wastages.
Right? So this option allows an administrator to select subnet sizes for his network that more closely reflect the actual number of hosts that need to be accommodated. So when we're doing VLSM, instead of studying how many subnets we need, we study how many hosts we need on the subnet. And we divide accordingly. Right? This reduces significantly the wastage of addresses that can occur with fixed length subnets. Because over here, we wanted 5 subnets, we end up having to get 8. And each of them have 510 possible hosts. But suppose on one we wanted 50 hosts, the next one we wanted 100 hosts, the next one we wanted 12 hosts, the next one we wanted 5 hosts. there would have been wastage, right? So over here, we're saying that we wouldn't have as much wastage as we do on fixed length subnet. For VLSM, subnet addresses ranges should be selected to be contiguous with already existing subnets. What do we mean by contiguous? Well, it's what comes next. Remember, when we did this one here, I tell you, well, when we reach here, we add one, and we go to the next one. And when we finish here, we add one, will take us to the next one. So the addresses on the first subnet is contiguous with the second subnet, and it's contiguous with the third because it's right next, it follows. Yeah, contiguous means side by side, right? So when we talk about, I have 5 lots of land on my street. I don't, I'm just speculating, right? I'm just giving you an example. If I say I have 5 lots of land on my street, or rather, let me put it this way. There are 5 lots of land on my street for sale right now. Okay? But they are not contiguous. What does that mean? Well, we have 1 lot up the road, then it have about 2 or 3 houses, then there are 2 more lots, then there are 2 more houses, then there are 2 more lots, there's another house. So it have the 5 lots, but they're not all one continuous piece of land. They're not side by side. So if somebody decide they want all 5 lots to be their own, so they will own one stretch of land, they can't do that because it's not contiguous. Right? So you have 1 lot available. You know, it have some houses. The round ones have houses. Then you have 1 lot, then you have a house, and 2 lots. Then you have a next house and 2 more lots, right? So they are not contiguous. If they were contiguous, it would have been house 1, 2, 3, 4, 5, and more houses. And somebody could have come and decided buying all that 5. See it? Contiguous, not contiguous. Yeah? So when we did the networks here, we have the first subnet, second subnet, third subnet, fourth subnet. They are all contiguous. And then the last one, that was not contiguous because this one didn't continue from the fourth one. Good? You see how long I take to explain contiguous. So, for VLSM subnet address ranges should be selected to be contiguous with already existing subnets. This means that a VLSM design requiring different sizes of subnet should allocate address ranges in order from the largest to the smallest. So we take out the largest one first, and we deal with that. Then the next one, and the next one, and the next one, until we reach the smallest one. So what we're going to do now is we are going to check smallest ones. So I'll explain this afterwards. It'll be easier then. Okay? So let's take a look now at one of these. I don't think we'll finish it tonight, but you will get enough to do the rest for homework, and then you'll be able to do your assignment. So here's a VLSM subnetting example. In this gray box, the calculation for the total number of host addresses will result is given. This will generally be more than the number of actual hosts. Forget that, right? So look at this network here now, right? Should I do it like this? Which one we should do first? Let me do the first one first. Let's just do the first one first. So this network is we're not seeing an internet connection and thing, it really don't matter. So what it is here, we have a router and it goes to a switch, right? With 50 hosts. And this one goes here to another switch with 50 hosts, with 75. Right? So how are we connecting these machines to the router? Obviously, right? There's your router here, right? So obviously, while they have the arrows pointing in different direction, it don't matter. Obviously, router not going to have 50 ports on each side. So we'll have one going to a switch, which we will use to connect our devices, our servers, and our printers, our database, web servers, what have you, our DNS server, wherever, on whichever machine. So all of these will have different IP addresses. Okay, so something will connect to wherever network. So we assuming there'll be a connection here coming from wherever. It could be our ISP, or it could be another router higher up in the hierarchy in our network. Okay, anybody have any questions there? So there are two subnets, one with 50 and one with 75. Good. The first step, class, is to convert the address to binary. So let's convert that to binary. No, let me do that with this. Let's go to our Word document, right? And we'll go to a new page. So this is,
We're not seeing the new pages.
yeah, that's okay. This is VLSM subnet examples, right? So A, B, what is VLSM? Examples, right? That's the name of that file, is it? A-B, A_B_ VLSM examples.update, right? This is example 1. So what happens here is they are giving us this address, right? Example 1, they gave us this, and we're going to get 2 subnets with 75 and 50 hosts, respectively. What do I mean by respectively? Anybody?
They are 79 hosts, 75 hosts on one and 50 on the other.
75 hosts on the first one and 50 on the second. If I had left out the word respectively, and I said 2 subnets with 75 and 50 hosts, people could be confused because they would think a subnet could have 75 and 50 hosts. So we would have 175 and 50 hosts on each subnet. That would be 125. You see the interpretation? And I told you in programming, and I'm telling you in the networking now, you cannot be ambiguous. You have to be very clear. So by saying respectively, you mean 75 on the first one and 50 on the second. So the first thing we do is we take this address and we convert it to binary, right? So we put that address, and binary, that is no 128, no 64, no 32, no 16, 18, no 4, no 2, no 1, right? Dot 9 will be the same thing. 0, 0, 0, 0, 1, and add 1 to it. That's 9, right? Is that correct? And then 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Slash 16. So what I'm doing here now is the slash 16 means that this here will be the network portion. We can't touch that. This here is host bits, right? But I want 75 75 hosts. The bigger one, we start with the biggest, right? 75 hosts is equal to 2 to the power of what?
7.
So 2 to the power of 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 is 64. So 6 bits is not enough. 2 to the power of 7 is 128, right? So 2 to the power 75 requires 7 bits, right? Because 2 to the power of 6 is equal to 64, which is not enough. Oh, you don't have to put it. I'm just putting it here so you will see my logic. It's not enough, right? And 2 to the power of 7 is equal to 128, which is like more than enough. Okay? Any questions? All you understand how I get that? 2,
Yes, sir.
2s are 4, 2s 8, 2 16, 2s 32, 2 64, 2s 128. So 64 is not enough. 128 is too much, but better more than less. So I will borrow 7. I will need 7 host bits. So it requires 7 host bits. Notice what I calculated there is host bits. So 1, 2, 3, 4, 5, 6, 7 host bits. Right? That automatically make these what? Subnet bits. Automatically. We don't care how much subnet bits we have. Right? So if I come here, so this is network portion. This is subnet portion. And this will be host portion. Now, mind you, all you should tell me, sir, or you wasting we time and because we do this already. Yes or no?
Yes, sir.
But
Yes,
nobody
sir.
telling me that, right?
Well,
No.
you said it.
So we can tell you how to teach your course.
No, you could tell me that if all you tell me, so we know that already. And? But based on the questions people have been asking, it means that they don't know it yet, right? Yes?
I personally don't mind speeding up.
Say that again?
I don't mind speeding up. I'm just speaking for myself.
Right, yeah. But the thing about it is
that's
I
it.
have to recognize, I have to recognize that I'm teaching a class where different people have different experiences and so on, right? So that's what we call a heterogeneous class.
Yes, I understand.
Right. So I'm glad if people know it and whatnot. I'm really happy. But you'll also notice my style of teaching. Yes? So now what happens here now is that we take out how many bits we need. Remember in the previous example, we identified how many subnets we needed and borrow bits accordingly, and the rest is host portion. Now we identify how many host bits we need, and the rest is subnet portion. Okay, so what happens now is when we do this and we identify these 7 are our host bits, this whole thing becomes our network portion. So it will be 16 and 8 is 24 and 1 is 25. So our new mask is now /25. So 25 bits here and 7 here is 32. Because we borrowed 7 bits, because we take 7 bits for the host portion, 7 from 32 is 25, automatically becomes our subnet mask. Right? Then we take this, check it out, and I put 1, that is my first host. See it? Then, when I have all 1s and a 0, that is my last host. Then, all 1s, which will be 7, 1, 2, 3, 4, 5, 6, 7, that is my broadcast address. You see it, class?
Yes, so basically just figuring out how much hosts you need for each subnet, and then you would
Right.
figure out how much bits you need to accommodate that number of hosts, and the rest will belong to the subnetted portion.
Exactly. Isn't that cool? So that's how we went from 75 to 7 bits. So we can cater for 128 hosts here. That will give us the 75 and growth possibly. Now, if we had 510 hosts, that would have been a different thing, eh? Plenty bits was wasting, plenty addresses was wasting there.
Say that I use that I have 2 octets for hosts alone.
Well, you see, so what happens now is we're gonna take this and we go, this here is our first subnet. So we go here and we put our first subnet. Yeah, so I'll put that in green. And then here now will be our green again, our second subnet. Ew. But our second subnet, we need 50 hosts. How many host bits we require? Well, 2, we're looking for 50, right? 2,
2 to the
2s
power
are 4,
7.
2's 8, 2's 16, 2's 32, 2's 64. So 5 is not enough, that's only 32. And 6 is 64 is too much, but that's the closest we could get. So we'll require 6 host bits because 2 to the 5 is equal to 32, which is not enough. So we will go with 2 to the power of 6, which gives us 64. Why do I have to explain about this being not enough? Because we're going to take too much. Why do we go and take too much? Because the one before was too little bit. Right? And sometimes you get stuff. Those of you who buy on Amazon, you will get a huge box with a little thing in it with plenty space. Well, the other box is too small, so they take the first one that is available that could fit. So we do that here. So we now want 6 bits we're using, right? That means with our host portion, we will have 6 bits. So that means our network portion, it will put back 1 here, right? So here now we'll have to remove this and remove this and remove this. So with all zeros now, notice is 25, this is 8, and 8 is 16, and 8 is 24, and 2 is 26, and 6 is 32. So our mask here becomes 26 because we taken 6 for our host portion. So 26 will be our network portion. So our first host address, so the
Sir.
one with all zeros, is our network address for the subnet.
Right, so it'll be 2 to the 6 minus 2. And will be 2 to the 7 minus 2.
That's the number of bits.
Yeah.
When you're minus 2, that's the number of hosts you can have. So nowhere do I have the number of hosts I could have.
So,
But that's the
sir,
host bits.
two AS
We want-
subnets.
We wanted 75, 64 was not enough. 128 is more than enough. Yes? But with this 128, I could hold 126 hosts.
Right, okay. Yeah.
And with this 64, 32 wasn't enough to give me 50. So I take 6, which should give me 64. And out of that, I could get 62 hosts, right? 2 to the power of n minus 2, you are right. That's the formula we use. So the information here is still correct. Good? So the first host, the first thing with all zeros, that is my network address, right? So we could put here, by the way, network address. So over here, there's the network address with all zeros. When I put 1, that's my first host. All ones and a 0, that's my last host. And all ones is my broadcast address. Good? That's my 2 subnets. Now, what we're going to do is we're going to convert to base 10. So this part here is 8.9.0.0, right? It's the same thing here, but now it is /25. See it? And over here will be the same thing, but .1. And over here, it will be the same thing, how much is this? We'll have to put this 8 bits together. This is 2, and 4 is 6, and 8 is 14, and 16 is 30, and 32 is 62, and 64 is, sorry, I made a mistake there. Right, 64 and 2 and 4 is 6, and 8 is 14, and 16 is 30, and 32 is 62, and 64 is 126. Okay, and the broadcast portion will be, I'll just copy it to save time, 127, one more, right?
Yes, sir.
So here, when we add one more, how much was this? 3 and 3, 6 and 1, 7. We had to take 1 less, but here's what happened, right? When we add 1 more here, we forgot to do something. When you add 1 here, you wouldn't end up here. You'll end up here. 1, 0. So you will end up with 1, 0. This is the next thing you will end up with.
So, and that's what I mean by contiguous.
Right, here, the next one.
Right, okay.
Okay, so my bad. When I add 1, I didn't bring it across here. It would have taken you straight to this one. Okay, you can't start with this here, add all of this, and then end up back here without this. Right, so this here was 127. What's the next value here? Anybody?
128.
128, that's the network address. Very good. See it? So after 120, so you get 0, 1, 2, 3, 4 until 126, 127. When you
So
add 1 more, you're going to the next network, right? You couldn't get 128 here on this network, but you get it here. Then When you add one more to 128, you'll get 129. See it?
Yes, sir.
And here would be,
So when you go into the third subnet now, you will be going into the third octet.
right, but before we do that, this here is 128, right? This is 2 and 4, 6, and 8 is 14, and 16 is 30, and 32 is 62, and 128 is how much? 62, and 128 is 190, right? That's 190. Is that correct?
Yes, sir.
And then let's bring it down to the next page so it'll all be together. And then this here would be 191. Because 191 and 64 will give you 255 possibilities. So 1 and 2, 3 and 4, 7 and 8, 15 and 16 is 31 and 32 is 63 and 128 is 191. Right? So if you add 1 to this, let's add 1 to it, we'll get 1. Let's do it. Add 1. So when you add 1, you'll get 0. Oops. 1, 2, 3, 4, 5, 6. And this will become 1. And well, we don't know about this yet because we can hold that up. This
Yeah.
is the,
This is given on next 50. If
right,
it was.
this is your next available address. Right? Which is, by the way, just to make stuff easy, 8.9.0.192. 128 and 64 is 192. See how they go in sequence? Contiguous.
Yes.
Is your next available address. And you could come and take this now and divide it how you want. Okay? You can make more subnets if you wish.
So, quick question. Why I kind of get a little foggy headed. Why in the second subnet it have 0.10 again?
Because the last value here we use .127, right? After 127 comes what next?
128.
Which is, this bit will be the 128 and all zeros.
Oh, 12. Oh, so that okay, I get you. When you join them together.
Yes, remember you have to, when you're converting them to base 10, you have to put them together between the dots.
Okay, I get. Oh, right.
Yeah. So what is the steps now? You get an address. They give you an address with a mask, right? You convert that to base 10, to base 2, and the mask will tell you what portion, how many bits you can't touch. The balance will now be your host bits, which you can touch. Then you look at what you need and work out how many bits you need for your host portion. The rest automatically becomes subnet portion, and you put that with your previous mask, and you'll get your new mask. So what is left is your host portion. You put a 1, that gives you your first host. All zeros and 1 is your first host. All zeros is your network address. All 1s and 0 is your last host. All 1s is your broadcast. Add 1 gives you the next address for your next subnet. And you take out the next biggest one at that point, and you repeat and repeat. So if we look here, right, you could fill it out. See, they do 2 to the power of 7, then 2 to the power of 8. Isn't that cool? But here, it tells you how many hosts you can have. This is how many hosts you can have. We just didn't do this bit. But that could tell you this is supposed to be the number of the last host. But it would not be the exact thing because you don't know what other bits you have. Any pre-existing bits could affect those values, right? So you could go and fill in this information here with your stuff, right?
So
So
for
they
for
let me do it
this,
here with the answers here, right? The network address, the first host, that they do it in base 10 here. And we got 191. Right. Somebody was asking that question. Oh, sorry, I'm pointing at token and I'm not showing you the correct thing. There's the document we was looking at, right? Here is where they see the number of hosts you can have, right? This was your requirements. So because you had 7 bits here for host, then you'll have 25 network bits, and that will be your mask. Because you need 6 for the hosts, that will leave you with 26 network bits, and that will give you your mask. And then we will call the first host by getting 1, the last host all 1s and 0. Sorry, and the broadcast will be all 1s. Then when we add 1 to this address, the next one will give us our network address and our mask. Add 1, it'll give us our first host. So all 0s and 1 in the host portion will be our first host. All 1s and 0 will be our last host, and all 1s will be our broadcast address. And these values are what we had in our document. So you could do this to, let's take a look at this one very quickly before you go, right? I really wanted to stop earlier, but that's how time is. So 256, 92, and 170. How many networks do we want in this one here? How many subnets?
8 will give 256.
No, how many subnets do we want on this network?
3.
3.
Right?
3 subnet, yeah.
But what about this one, guys?
Okay.
There's a subnet too, right? We connecting the router. Yeah? So we want 1 subnet, 2, 3, 4. But in this subnet, we only need 2 bits. How many bits will we need here for this network with 256?
8.
So we need 8 bits here, right? But this 256 is an issue here, right? Does this include network address and host address?
No, sir,
Network
that'll
address
just
and
be,
broadcast address?
no, sir. That'll just be users
How we know that?
in the assumption.
Is there any information here that could tell us that this is only hosts? That they didn't factor in the network address and the broadcast address. That this 256 does not include this. Anything here that gives us that information?
32.
What about this 2? How does this 2 help us?
So because they need to connect the both routers and the
Right. So
broadcast
this
and
2 means 2. Very good. This means 2 host address. 1 host here and 1 host there. But you still have to have the network address and the broadcast address. So if it's not included here, it's not included here. Seen it? Yeah? So 8 bits will not be enough for here because 8 bits will give us 256 minus 2, which is 254 hosts. So 8 bits will not be enough. So how many will we need? 9.
9.
How many bits will we need here for 2 host address?
You mean 2 to the power 2?
right? So we need 2 to the power 2, which will be 4 addresses. It will be 1, 2 hosts, and network and broadcast, because 2 to the power minus 2 is equal to 2. That's the 2 hosts. So here we need 9 bits. Here we need 2 bits. Here we need 92 is how much? 2, 2s are 4, 2s 8, 2 16, 2 32, 2 64, 2s 128. Right? So 7 bits for this one. And this one will be 8 bits.
8.
Right? Because 8 bits could give us 254 hosts. So if I clean up this is what it will boil down to. Two bits for here, 9 for here, 7 for here, 8 for here. This is a serial connection, but it's a network on its own, right? Remember, the routers have to have address, and they will be transmitting to each other on demand. Okay? And we could have a connection going to the cloud from here, or both. Yeah? Or it could just be to other parts of the company. Right? And then they could have connection to the cloud, wherever. So this could just be one department or one lab. Get it? Or one section, one floor of a building. So what we're going to do is we will take this address here, right? See how they work it out? They need 4 subnets. The first one we'll have to have 512 addresses. We need 9 host bits. Why do we need 9 host bits? Because here they did not include the broadcast address and host address, network address. So we gotta get 512. So almost half of that will not be used. With 270, we need 8. With 92, we need 7. And with 2, we will need 4 bits, 4 addresses. So 2 bits will be for that. So the total number of addresses required is that 900. That we not required. Total number, well, yeah, to be subnetted is this amount. We wouldn't need all that, but that's how much we have to provide. So required to provide. So when we come here now, we will come and do the same thing here. So we'll convert the address to binary, right? When we convert it to binary, we take this and we convert it to binary. Just bear with me for 1 minute, class, please. And we'll finish in a minute. So we'll go on a new page. We convert that to binary, which is what? 0, 0, 0, 8. No, sorry. 0. And then 1, 0, 0, 1, 0. That's tenant dot.
Here should be a /23.
Wait a minute, dot 8 dot 1, 2, 3, 4, 5, 6, 7, 8. All of them have 8. Right. So this 16 means that this first 16 we can't touch. Right? In the first one, we need how much? Here, we need 9 bits in the first one. And we needed 9 bits. Look at here. We need 9 host bits. So if we come here, we'll take out that's 9 bits. This will be our first subnet with 9 bits, which means that our thing will be 9 from 32 is 23. That's what you were asking, right?
Yeah.
This will be our thing, right? And very quickly now, we'll see our first host will be 1, right? Our last host will be, and then over here we'll have 1, 2, 3, 4, 5, 6, 7. We're just filling up the ones, right? And then our broadcast address would be the same thing, but with all ones. So network address, first host, last host, broadcast. And what's the next address we're gonna have available to us? This is our first subnet, right? The next one is when we add one to this, it'll go all zeros again, but here we'll have one. Right? Seen it? And how many bits do we want? We saw here, 8 bits, right? So if you want 8 bits, it means that here, this is where we're going for our next one. So this 0 will will come here and it will be a thing. So this 8 will now be /24 because 24 and 8 is 32. Right? So here we just have 1, 0 and remove this. And this will also be 1, 0 and take out this. And 1, 0 and take out this. So this will be /24 /24 /24. So this will be what? The next one after 10. 10.1.00. So let's be 10.1.2. Right? Because this is 10, this is 10.1.0.1. And this is 10.1.1.255. So this will be 10.2. When you convert that to base 2, you'll see this is .1.255. So this, our next one is 10.1.2.0. 10.1.2.1, 10.1.2.254, and 10.1.2.255. When you add 1, right? If you add 1 to this last one here, you will get this. Seen it? And
Yes, sir.
And when we check now our subnet, we will need 7 host bits. So 7 host bits means that we will be coming here now. See it? And this will become a subnet bit. And because that's 7, this is now 25. That is our network address. So this will be our first host. And it's 3 and 4, 7. 1, 2, 3, 4, 5, 6, 7. That will be our last host. Sorry. Only incorrect on me, you know.
So that'll be a broadcast.
This will be my last host, yes, with the 0. And my broadcast will be with the 1. When I add 1, very quickly, I will get this. After that will be, 1. Right? So this is 1, 2, 3. Right? 512, 128, and how much ever here? 64? Sorry, 512, 256, and 128. And the last one we will need 4. So over here, to get 4, for 4, I only need 2 bits. which will make all of these subnet bits. So I can pull that around here. So I only need 2 subnet bits. So 2 from 32 is 30. That's the smallest network I could have with only 2 addresses. So that is 128. See, after 127 is 128. That will be my first host. That will be my last host. And that will be my broadcast address. See it? So, oops. All you have to do is when you get the address, you work out how many bits for your first network you need, separate that, and then all the rest is network bits. So that's your mask. Put 1 here, that's your first host. Put all 1s and 0 here, that's your last host. And all 1s is your broadcast. And then convert them back to base 10 in the bunches of 8. Then you add 1 for your next one. And you do the same thing. How many bits you need? First one, last one, broadcast. Then you go again, how many bits you need? Separate that, the rest is your mask. Add
So
1, same thing, yes.
for the last one, how you get the 1 to go across to the next octet?
Oh, we didn't do that yet?
I know,
When you,
I don't know if it's supposed to be
when you add 1 here,
Yeah,
when you add here, this is what? How much is this? 3 and 3, 6, 7. That's 2 to the power 7 minus 1, which is 127. And
yeah.
so when you add 1 to that, you'll get 128. So there's 128. The next one is 128.
Okay.
And when you
So-
add 1, that's 129, 130, 131. So the next value available is 132. Yes?
Yeah, I see it.
And so why you jump from 25 to 30 with the slash notation again? I'll just
How many bits we needed on this network? How many bits we needed here to have 2 addresses?
2.
First 4 addresses we needed 2 host bits, right?
Yeah.
So if we take 2 host bits, how many is left to be masked? Altogether, we have 32. 2 from 32 is 30.
So
Yes? Does that make sense? You're not sounding like a show. Ask Thelma again. You understand how I get the 30?
yeah, we took it from the host bit. The
Right, there
host
was
bit.
2 here. I only needed 2 host bits. So all the rest become network bits.
Network bits.
So that will show up by having, that is my mask.
Okay.
I don't know if they have it in the answers. Do they have answers? Nope. But you could put it in. Let me see here, update. Right, you will see some answers here. Right? This is it in base 10. Right? This document here is what we're just doing here is base 2. So if you go on your canvas, which is, where is canvas? Oh, look at here. And we go to files. What do you have here? You've seen some slide examples, VLSM. There's the example from the slide. That is there. There's another example here. That was classical. So you have some of the things here. VLSM, example 1 demo. Let me see what that is. I don't know what that is. Oh, and we did this example. Yeah. So you have that. So there you go.
So the file we did just now, where that's it?
Which one?
The one you just did.
This one here? Right? You want it?
Yeah, that'll be nice.
All right. So we'll save as on this PC. Browse. And we'll call this one. What is it? VLSM slide example. Save. And then we go to our files here and we put upload and go to here and we take slide example and bring it over here. Is that it? Yes, now. Let me see what I have here. I just save it as something that's already there. Slide example. Yeah. How come it already gone? It already okay, it probably is there, right? Okay. So I'll say replace. Okay. So I'll replace it so it'll be updated with whatever. Is it there now? Right. So here it is. Hope I didn't show you something good. Right. So there's the first one we did. So this is some binary, right? I hope I didn't confuse myself and replace the wrong thing and change the wrong thing. Let me see. My document's still looking different from that one that you have there. So I don't know what went on. And why all this is there, but okay. So check it out, and if you all get trouble, don't worry, we'll fix it. Go through it and let me know if there's anything that's missing. Thank you very much for your patience and your time. Oh, it says unable to. So it must have gotten some problems. So here are some examples. So let me close this. And this one is an update. This one is just stamping. The machine had some problems. and I don't know what confused it. So it confused me now. So at the beginning of class, I asked a number of questions that would have been examples of what was coming on the quiz. And people tell me, yes, they know this and they know that, and cover it. You were here when we did that?
Yes, sir.
Right, so you're good to go there.
So what about the app? Anything with app coming or?
Anything with what, ARP?
Yeah, because I know we covered that last
Yeah,
last
nah,
class.
I don't think ARP coming in the quiz,
All right, cool.
right? Maybe I could put something in it so all you get some marks. Right? So yeah, but I don't think it has it for now. So that might be it. Okay. So keep well. Have a great evening. Thank you very much for your patience. I'll try and make up for this time I take from you tonight. Good. Keep well. Bye, everybody.
That's
Good
all
night.
right.
Yes,
Acknowledge
sir.
us.
Nice,
Was well
Take care.
received.
Good night.
Yes, sir. Good night.